Hi everybody, in this video today we're going to go through how to basically do everything about every type of quadratic that we've learned. So we learned standard, factored, and vertex form. We're going to go through and explain how to do every single piece that you might need to know. So we will start with standard form. To find the axis of symmetry, the equation is x equals negative b over 2a. So we will work out an example later on, but for now just know that that is the equation. How do you find the vertex? Well, the x is the negative b over 2a that we just talked about. And then the y value is you plug that in and you find out what the other value is. I'm just going to call that y for now because I'm saying we're plugging that in. And this is kind of messy. It says negative b over 2a. How to find the y-intercept? It's very simple. You plug in a 0 for x. And basically what that happens then is your vertex just is, or excuse me, your y-intercept is just 0c. You just take this last number and that's your intercept. Now the roots, we haven't learned that yet, so we're going to skip that for now. Okay, now let's go through an example of standard form and how to do all this stuff. So first of all, we will find the axis of symmetry by negative b over 2a. And that comes out to be negative 2. Then we're going to take that negative 2 and we're going to plug it into the function to find our y value. When you do this, make sure that you're using parentheses to plug in for your negative 2 and just be real careful with those negative signs because a lot of times that's what gets people tripped up. And so I'm going to go through and simplify this, and when I do, I get a negative 2 for my y value also. And that's just something you can plug into your calculator and get from there. Okay, now that I have these, I'm going to go ahead and start graphing them. Okay, so I'm going to plot my point negative 2 down here. I'm going to draw in my axis of symmetry. And now we have some options. Well, we need to do a couple other things. First of all, we know that our y-intercept is at 0, 6, so I can go there. And if I have a point there, I can reflect that over here. We didn't talk about how to find roots. We haven't learned that yet. If we did know that, we would put them in, but we don't know that. But what we do know is that odd number rule that we talked about the other day. Remember, the odd number rule says that you take from your vertex, you go up 1 and then up 3 and then up 5 and then up 7. Except here we have a 2, so we have to multiply this times 2. And so our odd number rule turns into 2, 6, 10, 14, etc. And so from this point, I can go up 2 and over 1, and then up 6 over 1, and now I'm here where I have that intercept that was 6 away. That's also kind of a nice little check. If it all works out, then you know you've gotten it right. And so now I'm finished, and I'm ready to connect my dots. Okay, I'm not always great on my board, but here we have our parabola. In addition, you need to know these key terms. So this one opens up. It has a min. Remember so this one opens up. It has a min. The axis of symmetry, we found that, negative 2. The vertex, we also found that, is negative 2, negative 2. We know the min-max value is negative 2. That's only the y value. It's not both, it's just the y. The domain is always from negative infinity to positive infinity. The range goes from the bottom, that's negative 2, all the way to the top, which in this case is infinity. There are two real solutions, and we can see what they are. We haven't learned how to do it, but we could tell by graphing it what they were. So one of them is at negative 1, and the other one is at negative 3. So I'm going to give intercepts on that. I'm going to say negative 3, 0, and negative 1, 0. The y-intercept did come out to be 0, 6. We calculated that. Okay, the increasing, decreasing intervals. Sometimes people get these a little bit off, a little bit confused on them. Remember that when we talk about increasing and decreasing intervals, we are talking about the x values. So like over here is negative infinity on the x-axis, and this is positive infinity on the x-axis. So from negative infinity all the way over to negative 2, it is decreasing. And from negative 2 all the way to positive infinity, it is increasing. The end behavior, since it's positive, it's opening up. Since it's opening up, both of these are going to be positive infinity. Okay, let's talk about factored form. For factored form, the axis of symmetry is you average the P and the Q. Now, you have to make sure that you remember these are supposed to be a minus sign, and so we'll talk about that in our example, but that is a positive P and that's a positive Q. Now, to find our vertex, what we do is we use that P plus Q over 2, and whatever we get for it, we plug it in to the original equation, and we get our y value. And again, we will work through an example. How to find the y-intercept, just like before, we're going to plug in a 0 for x, and then we're going to work it out. How to find the roots. The roots are very easy. It is the point P0 and the point Q0. All right, let's look at an example. So first of all, axis of symmetry is P plus Q over 2. In this case, that's 1 and negative 3 over 2. Okay, so that's 1 and negative 3. That's a negative 2 over 2. That is a negative 1. So I have an axis of symmetry here at negative 1. I also know my roots. I have a positive at positive 1, and I have another one at negative 3. So those are my roots. To find the vertex, what I do is I take this 1 and I plug it into this equation. And I might have said positive 1 a second ago. We're taking that negative 1 and we're plugging into the equation. So I get a negative 1/2 and a negative 1 minus 1 and a negative 1 plus 3. So that is, I'm going to put that into my calculator, and I get positive 2. And so that means that my vertex is at negative 1, 2. So I'm going to put my vertex right here. Okay, remember our odd number rule, 1, 3, 5, 7. However, with this odd number rule, we are going to divide it by half. And it's by negative 1/2, or divided by 2. We're multiplying by 1/2. It is negative, meaning it's going to go down that much. And so it's going to go down 1/2 over 1, and then down 3/2, which is 1.5 over 1, and then 2.5 over 1, etc. So I'm going to go down 1/2 over 1, down 1.5 over 1. So that's going to line up, and I'm going to come over here and do the same thing. I've got 1 here. If I wanted to do the next one, I'm going down 5/2, that's 2.5, and over 1. And on the right-hand side, that would be over here. And so now I'm ready to connect those points and make my parabola. Okay, let's see. The one thing we didn't do is we didn't calculate our y-intercept. So maybe I'm going to come down here. To find our y-intercept, we plug in a 0 for x. That's how you always find a y-intercept, is plug in a 0 for x. And so our y-intercept comes out to be 0, 3/2. That's like 1.5, which is right here where I put it. So a lot of times that 1, 3, 5 pattern is a way to check your work on some other things too. So that did land there at 1.5, and these did land on the points as well. And if we come over here, we can answer these questions. This one opens down because it's negative. If it's opening down, then the end behavior has to be negative infinity on both of them. It does have a max point because of that. We did calculate the axis of symmetry by averaging, and that came out to be negative 1. And then we plugged that negative 1 in, and we got the vertex of negative 1, 2. Our max value in this case is the 2. Again, it's just the y value. The domain is always negative infinity to positive infinity. The range goes from the bottom, that's negative infinity, and goes all the way up to the top, that is 2, and there is a square bracket there because it does touch the 2. It has 2 solutions, and we know what they are. They are 1 and negative 3. Sometimes we list those as coordinates like I did at the beginning somewhere, I don't remember where, but sometimes I list them as x equals. You need to pay attention to the word. If it says x-intercepts, definitely give it as a coordinate. If it says roots, you can kind of go either way. If it says solutions, say x equals. Okay, y-intercept, we just talked about that a second ago. That is 0 and 3 over 2. Increasing, remember, increasing is our x values. And so this over here is negative infinity, and over here is positive infinity. So it's increasing. I go left to right. It's increasing from negative infinity all the way up to -1. And then at -1, it starts going down. And from -1 to positive infinity, x values, it is going down. Last form is our vertex form. Actually, on vertex form, I'm going to go to vertex first and then go back to axis of symmetry because the vertex is HK. Remember, the H has a minus in front of it, but it's going to be H, and then K is just as it is. Now, the axis of symmetry is just the X portion of that, so it's just X equals H. The y-intercept, as always, we plug in a 0 for X and we simplify. How to find the roots. Once again, we haven't learned that yet. We will learn it next week. Okay, so as I look at this example, my vertex is going to be at 2, -12. And that's going to take me all the way down off the graph, but that's okay. I'm just going to estimate. Actually, my graph is pretty lame. You know what? I'm going to move my axis up. Okay, I just moved up my axis so I could fit this on better. I have 2, -12. I moved it up so that I can get to -10, and then I'm just going to make 2 more dashes here and say this is 2, -12. That tells me that my axis of symmetry is at 2, and that's what we said a minute ago too. It's at H, and that's the 2. I need to find my y-intercept. And the way I find my y-intercept is I plug in a 0 for x and I work it out. So this is going to be 4. That's going to be 0. Looks like 0, 0 is my y-intercept. Okay, how about some other points? Well, if there's a 0, a point over here, I'm going to come over here and make the reflection over here. My 1, 3, 5 rule, my odd number rule. I'm going to take my odd numbers, 1, 3, 5, 7, 9, etc., and multiply by 3. So when I multiply by 3, that's going to give me 3, 9, 15, and so forth. I'm not going to fit very many of those on the graph. So I'm going to go up 3. Remember, I made 2 hash marks, so up 3 is going to bring me right here. And I'll do the reflection. And then I'm going to go up 9. And indeed, that is up 9 from there. After that, I can't fit it. It's not going to be on the graph, but it's going to go up 15. And so it's super long like that. I'm going to fill in these terms again. I know you only have these terms once because I only had so much space on my paper. You can do however you want to do it. If you just want to write them down for one, that's what I've done in the past. But if you want to, put another page on your Google Form or a Google Doc, whatever you want to do. This is opening up because it's positive. If it's positive, then these are also positive. It's opening up. If it opens up, that means it has a min point. Axis of symmetry, we found that was positive 2. And that came from this 2 right here. The vertex was at 2, -12. We took that 2 from the axis. Oh, I was going to say we plugged it in. We didn't have to do that. It's just the right here, 2, -12 right here. What you really could do is take that 2, plug it in. That's going to give you 0, and then that's -12. Okay, the min-max value is only the y. It's a -12. The domain is always negative infinity to positive infinity. The range starts at the bottom. That's -12. Goes all the way to the top. That's infinity. -12 has a square bracket because it does include the -12. There are 2 solutions. Those solutions, we can see them this time. You can't always, but in this case we can. And one of them was 0, and the other one was positive 4. The y-intercept was 0, 0. The way we got that, we took 0, we plugged it in, and we see what we got. When we did that, we got 0. Okay, increasing, decreasing. Remember, increasing, decreasing are your x values. So we go from negative infinity all the way over here to positive infinity. So from negative infinity all the way over to 2, it's going down. So that's our decreasing interval. Then at 2, it turns around and starts going up, and that goes that way all the way over to positive infinity on the x's. All right, my hope on this video was that you could have everything in one place where you could know everything about graphing. Of course, everything, but we haven't filled in these two yet. We can fill those in later. So I hope this helps you to organize your information.